Before guns, before cannons, before rifles, before bullets, before armies could break castle walls with fire and iron, humans discovered something they were not even looking for. They were not trying to build a weapon. They were not trying to change warfare. They were not trying to end the age of knights, forts, swords, and siege towers. They were trying to live forever. That is the strange beginning of the gun. Not a battlefield, not a king's workshop, not a soldier's hand, but an alchemy room in China, where Taoist experimenters mixed minerals, heated substances, followed old recipes, and searched for an elixir of immortality. They wanted life without death. Instead, they found fire that could explode. Somewhere in the 9th century, Chinese alchemists discovered that certain mixtures of saltpeter, sulfur, and charcoal could burn with sudden violence. The result was called huo yao, fire medicine. That name is almost funny now, because the thing that began as medicine would become one of the most important forces in the history of war. Fire medicine did not make humans immortal. It made them more dangerous. And that is the irony at the center of this story. The search for eternal life helped create a technology that would make death travel faster than ever before. So how did humans get from a failed immortality experiment to the firearm? The answer is not one invention. It is a chain of accidents, experiments, sieges, trade routes, empires, craftsmen, soldiers, and small improvements repeated for centuries. No one invented the modern gun in a single moment. No one saw the whole future inside that first flash of powder. Instead, humans kept asking one practical question: how can we control the explosion? First, gunpowder was spectacle. In early China, it was used for fireworks, smoke, noise, signals, rituals, and festivals. It lit the sky. It frightened spirits. It made celebrations louder. It turned darkness into color. At first, people did not see it mainly as a battlefield technology. They saw it as wonder, a controlled piece of thunder, a strange fire that did not behave like ordinary flame. That matters, because many of humanity's most dangerous inventions did not begin as weapons. They began as curiosity, as medicine, as entertainment, as ritual, as experiment. Then someone noticed what else they could do, and during the Song dynasty, military engineers began to notice. China in this period was full of pressure: sieges, border wars, rival states, defensive walls, armies trying to take cities and cities trying to survive them. In that world, any technology that could frighten, burn, blind, or break an enemy became valuable. So fire medicine left the festival and entered the battlefield. The first step was not the gun, it was the fire lance. Now move the map to Song dynasty China. Imagine a spear, but with a tube fixed near the blade. Inside the tube was gunpowder. When lit, it blasted flame and sparks forward toward the enemy. The early fire lance was not a firearm in the full later sense. It was closer to a terrifying flame weapon. Short range, loud, bright, dangerous, perfect for shock. During the siege of Dian in 1132, Song defenders used fire lances against attacking forces. Think about what that meant for a soldier climbing toward a wall. For thousands of years, war had been steel, wood, flesh, arrows, stones, and muscle. Then suddenly, the wall breathed fire. The physical damage mattered, but the psychological damage may have mattered even more. A spear can be blocked. A sword can be understood. A fire lance looked like the battlefield itself had become unnatural. This is one of the earliest turning points in the history of guns. The weapon did not yet fire a bullet like a later firearm, but it introduced the core idea. A human could place explosive force inside a tube and direct it toward another human. That idea would change everything. Once people understood that a tube could guide fire, the next step was almost inevitable. What if the tube did not only spit flame, what if it threw objects? Engineers began adding fragments, pellets, or hard materials into the blast. Now the weapon was not only burning, it was projecting. It could send material outward with force. This was the conceptual birth of the gun, not the finished weapon. The idea: fire could push, gas could throw, a tube could aim. The problem was that bamboo and weak materials could not handle stronger explosions. A tube that bursts in your hand is not a weapon. It is a mistake with consequences. So the next transformation was material, from bamboo to metal. Bronze and iron could contain more pressure. A stronger tube could send a heavier projectile farther. And once the tube became metal, the hand cannon became possible. By the 13th century, metal-barreled hand cannons were appearing in China. They were crude compared with later firearms. Heavy, slow, hard to aim, difficult to reload, but they were real. A metal tube, a charge, a projectile, a human hand directing explosive force. That was enough. Because history does not need the first version of a technology to be elegant. It only needs it to work well enough for people to keep improving it. Now move the map north and west, to the Mongol world. When the Mongols fought Chinese states and eventually ruled China under the Yuan dynasty, they encountered gunpowder weapons directly. And the Mongols were very good at one thing history often underestimates. They learned from what they conquered. They did not simply destroy technologies. They absorbed them. Engineers, craftsmen, siege specialists, and weapons knowledge moved with Mongol armies across Eurasia. This is one of the great technology transfers in world history. Gunpowder did not spread only through peaceful trade. It spread through conquest, through siege warfare, through captured specialists, through armies moving across enormous distances. From China, the knowledge traveled into Central Asia, the Islamic world, and eventually Europe. The road of gunpowder was not one road. It was a web. Merchants, soldiers, prisoners, craftsmen, diplomats, scholars, empires. The same broad routes that carried paper, printing, and the compass also helped carry the technology of controlled explosion. The world was becoming connected long before anyone called it globalization, and gunpowder was one of the things that moved. Now move the map to the Islamic world. Gunpowder weapons were studied, adapted, and used in siege warfare. Cannons became important because cities mattered. Walls mattered. Fortresses mattered. A medieval city could survive for months behind stone. But gunpowder changed the conversation between attacker and defender. A wall that could resist arrows, ladders, and stones might not resist repeated cannon fire. The psychology of the fortress began to change. For centuries, height had been power. Tall walls, high towers, vertical dominance. But cannons punished height. A tall, thin wall could crack. A tower could collapse. The old castle had been designed for arrows and climbing men. It had not been designed for heavy artillery. And when cannon fire grew more powerful in Europe, architecture had to answer. Now move the map to Europe. Early European guns were awkward. Hand cannons were slow, smoky, inaccurate, and dangerous. A soldier had to load them carefully, aim with difficulty, and ignite them manually. Compared with a trained archer or crossbowman, an early gunner was not always impressive. But the gun had advantages that would grow over time. It could punch through armor. It could frighten horses. It could be learned differently than the lifelong training of a knight or elite archer. It could improve with metallurgy, chemistry, drilling, and manufacturing. And most importantly, it could scale. A better bow still depends heavily on the archer. A better gun can make an ordinary soldier more dangerous. That is why firearms did not only change weapons, they changed power. For centuries, heavily armored knights dominated parts of European warfare. They were expensive to train, expensive to equip, tied to land, status, and feudal power. But gunpowder weapons began making armor less reliable. Not instantly, not in one dramatic moment, but steadily. The knight did not vanish overnight. The castle did not fall in one afternoon. But the direction of history had changed. A world built around elite muscle and inherited military status was being challenged by powder, metal, and drilled infantry. As cannons improved, forts changed too. The tall medieval castle gave way to lower, thicker, angled fortifications. The Tres Italienne, or star fort, used geometry against cannon fire. Instead of simply building upward, engineers built outward. Angles, bastions, thick earthworks, overlapping fields of fire. The shape of cities changed because of gunpowder. That is how powerful the invention became. It did not only kill people, it redesigned the landscape. But the gun still had one major problem: ignition. Early hand cannons were clumsy because firing them required a human to bring flame to powder while trying to aim. That sounds simple until you imagine doing it in rain, smoke, panic, and battle. The next great invention was not a stronger barrel. It was a better way to fire. The matchlock solved part of this problem. Instead of applying fire by hand, a burning cord was held in a mechanism. When the trigger was used, the match moved into place and ignited the priming powder. This freed the shooter to hold and aim the weapon more effectively. It sounds like a small mechanical change, but small mechanical changes can alter entire civilizations. The matchlock turned the firearm into a more practical infantry weapon. Now armies could train groups of soldiers to fire in formation. Musketeers appeared beside pikemen. The pike protected the gunner from cavalry and close attack. The gunner gave the formation firepower. This became the age of pike and shot. Lines of men, smoke, drills, commands, noise, slow reloads, long weapons, and a battlefield becoming more organized, more mechanical, more disciplined. The gun did not make war simpler. It made war more coordinated. A sword fight is close and personal. A matchlock battlefield is timing, formation, and smoke. This is another hidden change in the history of guns. Firearms did not only change what soldiers carried, they changed how soldiers moved together. Now move the map to the Ottoman Empire. The Ottomans became skilled users of gunpowder weapons. Cannons helped reshape siege warfare, and firearms became part of elite military systems like the Janissaries. Now move to Japan. In 1543, Portuguese traders introduced matchlock firearms to Japan. The Japanese quickly copied and refined them. These guns became known as Tanegashima, after the island where the technology first arrived. Japanese gunsmiths improved production and quality with extraordinary skill. Within decades, firearms played a major role in Japanese warfare. At Nagashino in 1575, forces using large numbers of firearms helped demonstrate how disciplined gunfire could break older cavalry tactics. Again, the pattern repeats. A foreign technology arrives. Local craftsmen adapt it. Local armies change around it. The gun is never just copied. It is absorbed into a culture of war. Now return to China. The country where gunpowder began also reabsorbed improved firearm technologies from abroad. Ming China adopted and adapted matchlocks, including weapons sometimes known in English as bird guns. That is one of history's strange loops. A Chinese discovery traveled west, was changed by other societies, and then came back in new forms. Technology is not a straight line. It is a circle of borrowing. China to Eurasia, Eurasia back to China, each culture adding something, solving one problem, creating another. But the matchlock still had a weakness. It needed a burning match. That meant smoke, smell, delay, weather problems, and danger. Rain could ruin it, darkness could reveal it. A soldier had to manage fire even before the battle began. So inventors searched for ways to make sparks without carrying an open flame. One answer was the wheel lock. It used a spring-driven mechanism to create sparks. It was clever, compact, and useful especially for cavalry and wealthy users, but it was expensive and complex. A fine wheel lock could be beautiful, but armies need thousands of weapons, not just clever objects for rich men on horseback. So the matchlock remained common for ordinary infantry for a long time. Then came the flintlock. In the early 17th century, French gunsmith Marin Le Bourgeois is associated with developing the true flintlock system in a form that spread widely. The basic idea was more reliable and practical than earlier systems. A piece of flint struck steel, making sparks that ignited the weapon. No constantly burning match. Better performance in more conditions. Faster handling. Less visible preparation. For about 2 centuries, flintlocks dominated much of global firearm history. They were used in European wars, colonial expansion, the American Revolution, the Napoleonic Wars, and countless conflicts across the world. The flintlock became the weapon of empires. Long lines of soldiers, smoke clouds, volley fire, bayonets, drums, commands, flags. The battlefield became an industrial rhythm of human bodies and mechanical ignition. And the bayonet changed the gun again. Earlier musketeers needed protection from close attack. That is why pikemen stood with them. But once bayonets could attach to the end of a gun without stopping it from firing, the musket became 2 weapons, a ranged weapon and a spear. This helped end the old pike and shot system. Every infantryman could now shoot and also meet a charge. The gun absorbed the spear, another ancient weapon folded into the firearm. That is what guns kept doing. They did not simply replace old technologies. They swallowed them. The fire lance swallowed flame. The hand cannon swallowed the thrown stone. The musket swallowed the spear through the bayonet. The rifle would later swallow distance. Repeating weapons would swallow time. But before that came one last great ignition change, the percussion cap. In the 19th century, percussion systems made firearms more reliable by replacing older priming methods with impact-based ignition. This made weapons less vulnerable to rain and misfire compared with flintlocks. Within decades, older lock systems became outdated. Matchlock, wheel lock, flintlock, all belonged to a previous age. The gun had become more dependable, and once industrial manufacturing, rifling, cartridges, and repeating mechanisms advanced, firearms moved into a new world entirely. But the deeper story had already happened. The human hand had learned to command controlled explosion. That is the real history of guns. Not one invention, not one nation, not one genius. A chain of small solutions across centuries. Chinese alchemists discovered fire medicine while seeking immortality. Song engineers turned it into flame weapons. Chinese craftsmen strengthened tubes into hand cannons. Mongol conquest helped move the knowledge across continents. Islamic and European engineers adapted cannons for siege warfare. European battlefields reorganized around firearms. Castles changed shape. Knights lost dominance. Matchlocks made guns more practical. Wheel locks made ignition portable for some. Flintlocks made the firearm faster and more reliable. Bayonets merged gun and spear. Percussion caps ended the long age of spark and match. Each step solved one problem: how to burn faster, how to contain pressure, how to aim, how to ignite, how to reload, how to survive weather, how to protect the shooter, how to make the weapon reliable enough for armies. That is how humans invent, not by seeing the final machine at the beginning, but by solving the next frustration, again and again. And the strange thing is that the story began with the opposite of war. It began with people trying to escape death, people seeking immortality, people mixing substances because they wanted the body to last forever. Instead, they discovered a force that would change how bodies died. That is the irony of gunpowder. A failed medicine became a weapon. A search for life became a technology of killing. A spark in an alchemy room became cannons at city walls, muskets in empire armies, and firearms carried across every inhabited continent. So the next time you hear the word gun, do not imagine only the final object. Imagine the whole chain behind it. The Taoist alchemist, leaning over a dangerous mixture. The Song defender lighting a fire lance on a wall. The bronze founder casting a stronger tube. The Mongol army carrying engineers westward. The cannon breaking a medieval wall. The matchlock soldier trying to keep his burning cord alive in the rain. The Japanese gunsmith refining a foreign design. The flintlock snapping sparks into smoke. The infantry line fixing bayonets. The percussion cap, ending centuries of open flame. The firearm is not just a weapon. It is accumulated history. A memory of chemistry, fear, empire, craftsmanship, accident, and ambition. Humans did not invent guns because one person wanted the modern world. They invented them because fire escaped the laboratory and entered human conflict. And once that happened, every society that touched the technology had to answer the same question. Can we control this before someone else controls it against us? Before guns, power belonged to muscle, walls, horses, armor, and numbers. After guns, power began moving toward chemistry, metal, discipline, and machines. The battlefield changed, the castle changed, the soldier changed, the state changed, and it all began with fire medicine, a name that still carries the memory of the mistake. Humans wanted immortality. They found explosion, and history has never stopped living with the consequences.